Hello, everybody. It's really nice to see you, a big audience, and a great topic. I'm really glad to talk about artificial intelligence, not just because of my past in North Carolina State University, but also because it's a really hot topic today, and it aligns really well with healthcare. So today I'm going to talk about training artificial intelligence by using national healthcare data. That's the topic today. And I'm talking about it from the perspective of business. I'm talking about it from the perspective of perhaps making a next huge export from Finland to other countries. Okay. So, the main thesis all around today is that there is lots of good healthcare data in Finland. Another part of the main thesis is that healthcare IT is a booming business. It's a megatrend. It's happening everywhere. Everybody wants to be a healthcare startup. It's a phrase I heard today. And artificial intelligence is the third component. It's a megatrend. It's finally waking from the AI winter that we had in the 80s and in the early 90s. AI winter means that artificial intelligence was dead. It was not used in the business. It was a bad word to use in business. You didn't put yourself in good light if you wanted to sell artificial intelligence projects. Today, in 2019, it's now becoming a benefit. If you know something about AI, if you can solve problems by using AI, it's good for you. And as a result, of course, we're looking at a holy grail. Well, obviously not. It's not a holy grail, but if we melt the holy grail, we'll still get a lump of gold, and that's better than nothing. So what are general applications of artificial intelligence? I'm listing a few. Natural language processing is one. Generation of speech, capability to understand speech. That's one important aspect. Machine vision, computer's ability to see, to understand what it sees, and to create structural information of what it sees. Decision support, that's an important part of artificial intelligence. So when we make decisions as humans, we are not able to take into consideration all the data that is available to us. Computers can help us do that. Also the same thing with planning and scheduling. If we play chess, we can only take into account perhaps 10 different alternatives and perhaps 1 or 2 different steps ahead. But computer can calculate a lot more forward. Computers can do predictive analytics, and computers and artificial intelligence can be used in robotics. And it's almost obvious that all of these general applications of artificial intelligence can be applied in healthcare and medical area as well. But if we go into the specific medical and healthcare applications of artificial intelligence, there are the first one is interpretation of radiological images. This is something that the doctors and especially radiologists have been afraid for a long time. But I think today people are learning that it's not going to take their jobs away. It's going to transform their work into more productive work instead of creating an army of unemployed radiologists. I don't see that happening. Diagnostics with computer aid, that's a big issue, big topic. Are we rendering Dr. House unemployed? I don't think so. But we're giving him a lot of help by creating artificial intelligence solutions. Then, this is perhaps the most hot topic today, pre-emptive healthcare. The ability to predict, the ability to see if there are healthcare or social problems within a community, within a country, or perhaps by predicting a single person's problems and perhaps do some measures, take some measures before those problems appear. That's a lot cheaper than fixing those problems when they are already happening. Clinical decision support is one thing. We can automate customer service with artificial intelligence. And of course, we can use AI to make more rapid development of pharmaceuticals. So there's a lot of really, really potential applications for artificial intelligence. So, but my speech was about training artificial intelligence with healthcare data. So what's the relationship between AI and data? Clive Humby said data is the new oil. In the Gartner hype cycle, we saw big data. It was on the highest peak of hype cycle something like 3 or 4 years ago. Today we are at a point where artificial intelligence is at the peak of the hype cycle. But together they are something new. Big data alone, it isn't much use. Like, you can have a lot of data, but if you don't have the capability to do anything with it, so what? So I think the fuss about big data was that when we have the capability of creating artificial intelligence or different intelligence and analytics based on that big data, then it becomes valuable. And now when we're combining these two, we are at a point where we can actually have some business impact. But let's take a bit closer look at what AI and how AI and data revolve around each other. The first two, so-called good old-fashioned AI methods, were symbolic AI and logic and fuzzy logic. These are the stuff that I studied 20 years ago. Search and optimization and swarm intelligence. You can implement this stuff without having a lot of data. But when you jump to 2020 or 2019, and we are at a point where we have huge amounts of data. We have terabytes, petabytes, zettabytes of data everywhere lying around. Statistical methods, probabilistic methods become more interesting, but they are still old school stuff. Neural networks, support vector machines, evolutionary algorithms, these are something that are being used today. And each of these algorithms, each of these methods rely more and more on data. So further we go to the right on the diagram, the more we'll rely on data. And today we're talking about machine learning and deep learning, which is sort of a buzzword for just deeper neural networks. But anyway, so the evolution of artificial intelligence is simultaneously also the evolution of data. So we are going from human-programmed algorithms to small data sets, to big data sets, and to complete environments where the artificial intelligence algorithms can learn from the data that's surrounding them. So artificial intelligence needs data to evolve. If today somebody claims you that they're key players in artificial intelligence, but they don't have knowledge or capabilities to deal with big data, I don't think that's a credible thing to say. So back to the data is the new oil premise. So on one end, I think it's true. Data is just like crude oil. It's valuable, but it's valuable only if it's refined, or in the case of data, analyzed. But this is also, at the same time, it's an insult to data, because data is clean, and oil is something that when you use oil, it vanishes, it destroys environment, and it's especially an insult to big data. Big insult to big data. So the way I see data is, I see it as recyclable, reusable, and unlimited resource. Obviously, it's not problem-free, because when we talk about data, we also talk about our personal lives and very important and things that are classified, things that we don't want people to know. We want to be on the safe side with data. And we also don't want to build our systems so that data is not hoarded by organizations. This thing is already happening, and there are some data that we have given permission for big organizations to collect from us and use it for business. But we haven't given all power to businesses yet. And a lot of governments in Europe, etc., are making very good decisions today to govern the way that data is reused and the way that data is collected. And for example, GDPR. I personally think that GDPR is a good thing. But I see data as a more green thing than oil. If we go into the concrete stuff, how can we use healthcare data in Finland for secondary use? Secondary use means the use of healthcare data for purposes that it has not been originally collected. Primary use is the main collecting reason for the data. For example, if I go to see a doctor, and the doctor collects data from my body or from my history, they're doing it to treat me. But if somebody uses that data to create an analysis or to do research for medical, let's say pharmaceutical purposes, or for organizations' own purposes, then that's not primary use. Then the data is used for its secondary use. And today, the legislation with secondary use is lagging behind. But there are certain silos of data, so to speak, in Finland where the data can be fetched for secondary use. And really important are, for example, the Finnish biobanks. And also some innovative organizations have been leaning forward, and they have understood that it's important to start building data lakes, organization-specific data lakes, which connect data from different operative systems and collect it to data lake where it can be used for research purposes. And then, of course, we have the national health record. But I have a question mark at the end of it, because it's not so clear what's the situation with it. We cannot use it today, and I'm going there quite soon. Of course, in addition to these ones, there are other possible sources. So we have a genome law draft from the social ministry from last year, which proposes the building of genomic data center. We have different national health registers and different service statistics and socioeconomic data sets. And of course, we have the operative social and healthcare IT systems, which contain data that we could use for research purposes. But if we want to go to the actual mother source, if we want to go and start using national health record in Finland for research purposes or for purposes of training artificial intelligence, then let's stop for a while and see what data is available in our national health record today. So the national health record contains the archive, the clinical archive, which contains the actual medical record of you and me. It's been mandated by law since the year 2014 that public organizations store their medical records to national health record. It also contains information about prescriptions. It's the same thing. I think the prescriptions have been online since the year 2011 and mandatory from year 2014. There's a place in our national health record for old IT systems data. So it's possible for an organization to stop running their old systems, which they don't use anymore, and just transfer all the data to the national health record. It's a big cost saving. And then Omakanta, which is the personal health record. It's a part of the national health record which contains information generated by ourselves with our own personal devices instead of data which would be produced by the healthcare organizations. And then last, but definitely not least, the social welfare information. This is information that is collected by the social welfare IT systems. And that data is also flowing to the national health record. So we have all this stuff in our Finnish national health record, and wouldn't it be great to start training artificial intelligence based on all this data? If we look at it in numbers, we see that there are, these are actually old numbers, sorry. 2017, there was 32 million e-prescriptions and over 1 billion medical records in our national health record. But can we use it for secondary use? And I'm sorry to say, but today legislation only allows to use the electronic prescription data. And obviously you will need to go through quite a hassle. You'll need to ask permission from THL, the National Institute for Health and Welfare, or depending on the data, you might also need to ask some permissions from Kela. But if you want to start training your AIs or doing analysis or whatever with the healthcare data or social care data, doesn't work yet, not supported by legislation. And I think the same thing is with personal health record. It's sort of, because the data is not, that data is belonging to us. So it's we the people, I myself as a person, control what's being done to the personal health record. But if I've read the legislation correctly, and also how the Kanta has been built, there is not yet a method for conveying that data to the researchers. But there is light at the end of the tunnel. Government is wise, or at least some people who are proposing stuff there. So they're proposing a new act on the secondary use of health and social data. And the aim is to ensure flexible and secure use of data by establishing a centralized electronic license service and an authority for the secondary use of health and social data. And there's a link. I'm not going to cite the law here, but there's a link for people who are interested. And for the technical purposes of that law, Kela has also started preparing a project which they call National Health Record Data Lake. And the goal of that project is to enable the technical capability for Kela and Kanta to yield data for research groups for purposes of secondary use. And this is the topic that I'm talking about today. Training artificial intelligences with national health record data. So we are at the verge of something really cool. If we really get to that point, we can start cooperating with universities and with companies who can do this. But what should we focus on if we really want to build good business and good added value? So we need to focus on developing AI services that utilize the data. We need to sell the refined artificial intelligence services as SaaS. We must not sell the data itself. This applies to all the data that we're collecting. Because new breakthrough findings and innovations that are based on data, they are less common, and it's really difficult to monetize those. But if we just focus on analyzing the data, we're not getting the full potential of the data. But if we build artificial intelligence services that can answer different customers' questions multiple times per second, and sort of create a model out of the data without giving the data away, then we're adding more value to the data, and we're also developing something that's more lucrative, better business than just analyzing the data ourselves or shipping the data away in anonymized format. So we need to build the AIs and sell them as SaaS services. Thank you very much.